All right, here we have three-wire distribution type question, and we're trying to solve for the current going through A, which is going to be line 1, C, which is line 2, and then the conductor that splits the 120 volts and the 120 volts here. That's our neutral, which you can see is grounded. All right, so we're trying to figure out what the current is going through B, and then also through D, this point here. So in a three-wire distribution circuit, we can see that this particular load, the 3 ohms here, is connected up to 120 volts, or right across this 120 volt part of the transformer. So this particular load then is going to see 120 volts. Because it has 120 volts across it and we know what the resistance is, we can figure out what the current is by dividing the resistance into the voltage, and we know that there is 40 amps going through that particular resistor. Likewise, this 7 ohm resistor is connected across 120 volts via the neutral and line 2, so we can say that that load is seeing 120 volts as well. So we can divide its resistance into the voltage, 120 divided by 7, which gives us 17 point, we'll call it 1 amp. All right, so we know the current going through both those 120 volt loads, and we also have the 19 ohm load as well. So the 19 ohm load is going actually across line 1, directly across line 2. So that's going to see the full extent of our source, 120 volts and 120 volts, which is 240 volts. Now we can take that 240 divided by 19, and we have a current of 12.6 amps going through that there. Now it's always a good idea to give our current a direction. So let's say our current is going out of line 1 this way. Because we're dealing with 100 or AC, our current's going to be changing every 120 times a second. So our current's going to go out of line 1 and back into line 2 in our particular case. If it was going the other way, no big deal, but let's stick with clockwise. So out of line 1 then, we need enough current to feed 40 amps into our 3 ohm resistor here, as well as the 12.6 amps going into this resistor here. So we can, Kirchhoff says that the current going in to a junction must equal the current leaving that particular junction. So this is our junction here, and so we must have 52.6 amps flowing out of there. All right, if we have 52.6 amps flowing out this way, that gives us our A value. So A equals 52.6 amps. Our D value is simply going to be the current going through this load here, and that is going to be 12.6 amps. So our current goes in that direction through that load, and we get 12.6 amps. All right. Now we also have current going through line C here, and there must be enough current leaving line C to handle that 17.1 amps as well as that 12.6. So we get 17.1 plus 12.6, which gives us 29.7 amps. So one thing to notice here is that this particular three-wire circuit is not very well balanced. We have 40 amps going through that load and 17.1 1 amps going through that load, 52.6 going through line 1, 29.7 amps going through line 2. That's not necessarily how we want to design a three-wire circuit. We want to try to make A and C as equal as possible. In this case, it's not a poorly designed circuit. Either way, 29.7 amps going through C. Now, for B, through the neutral, if we have 52.6 amps flowing out of our source via line 1, we must have 52.6 amps flowing back into the source. Now, in this particular case, we got 29.7 amps flowing back into the source. So the balance has to be going through our neutral, which is going to be the difference between 52.6 amps and 29.7 amps. So we're going to go 52.6 minus 29.7. It's going to give us 22.9 amps. So ideally, through neutral, you got no current, but in this particular case, we got 22.9 amps, a very unbalanced type circuit. Now, one last thing to mention is we need to know the direction of the current flow. It's a good idea to know the direction of the current fluid going through the neutral at any given point. So we've got 52.6 amps leaving, 29.7 amps returning. We must have that 22.9 amps returning to the source as well, so that now what is leaving the source is now coming back to the source. 29.7 plus 22.9 equals 52.6.